Today we're looking at notes JJ-1 Calculus Prep Day 3. So we will be exploring in the calculator as well as looking at extrema. So in part 1 we'll start with the extrema. So when you're asked to find the extrema, that means to find all relative max or min on a graph. So that's essentially what page 38, number 37 is asking. You're asked to find any relative max or mins of the equation y equals 2x cubed plus 3x squared minus 12x. So I've already cleared my calculator to restore any settings, and I have then entered this equation into the y equals. Okay, so now I'm going to look at the graph, and you can see my relative max goes outside of the window that I have. This is, remember, I cleared my calculator, so this is just the original setting for the window. So I know I need to adjust my y max. It's currently at 10. I'm going to try 20. So it looks like that'll be enough. Let's try it. So now I can clearly see my relative max. So I'm going to do second trace and 4 since I want relative max. So it says left bound. I have to scroll my cursor to the left of the max, hit enter. Right bound, so scroll my cursor to the right of the relative max, hit enter. You should see, you might not be able to see at home as clearly, but on your own personal calculator, you should see that relative max lies in between the two vertical lines that have been created on the graph. So then I hit enter, and you can see I have negative 1.999999 and comma 20. So your bet that that's negative 2 is a pretty good bet. We're going to verify with the table. So second table, we should have negative 220, and we do. Okay, so negative 220 is our relative max. So max is negative 2 comma 20, and we did have to check the table to verify, so you should check that table to verify. Another thing to look at when you're looking at the table is notice the y values on either side of this y value here at 20 are both decreasing. They're both less than 20. Okay, so that indicates to us that that negative 220 is our relative max. So now to find the relative min, so second trace, but now number 3 for relative min, scroll that cursor to the left of the relative min, then to the right of the relative min, hit enter again. So we have about 1.000025 and negative 7, so that looks like about 1, negative 7. Let's use the table to verify. So 1, negative 7, and again you'll notice the y values around this y value of negative 7 are both increasing. They're both higher. Okay, so our relative min would be 1, negative 7. So I'll box this answer. So that's extrema, or in other words, both relative max and min on a graph. So next would be increasing and decreasing intervals. So when I say the word intervals, I mean x's. Okay, so you want to give the x values for which the graph is increasing or decreasing. So we're going to look at page 38, number 22. So page 38, number 22, I'm going to try and bring it on over. Okay, so this right here is number 22 on page 38. Okay, so I want the intervals for which this graph is increasing. So if I scroll left to right, my graph is increasing from negative infinity all the way to negative 1. Okay, so I'm going to say from negative infinity. So I'm increasing from negative infinity to negative 1. Remember, we use parentheses for this. Okay, we're looking at the open interval, so from negative infinity to negative 1. And then I start decreasing from negative 1 to 0. Okay, and then from 0 to 1, I'm still decreasing, but then from 1 to infinity, I start increasing again. So then that's union with, from 1 to infinity, I start increasing again here. So from 1 to infinity, I start increasing again. So let's talk about the decreasing interval. Okay, so on the x-axis, remember that's my interval. On the x-axis, I'm looking at negative 1, from negative 1 to 0. You can tell there's an asymptote here. From negative 1 to 0, this graph is decreasing or falling. Okay, and then it picks up again on this part of the graph, and again from 0 to positive 1, I am also decreasing. So that would look like from negative 1 to 0, union with 0 to 1. 0 to 1. Those are my decreasing intervals, and you can still see the graph here in the picture. Okay. And we've talked about increasing and decreasing in previous lessons, so if you need to refer back to that, please do. All right. Next, part 3. Where is f of x greater than or equal to 0? So in other words, where is the graph above the x-axis? Because this means where are the y values greater than or equal to 0. So the y values are 0 on the x-axis, and the y values are greater than 0 above the x-axis. So this really means where is the graph on or above the x-axis? On, because of the or equal to. So you really need to calculate the x-intercepts, okay, or find, not necessarily calculate, but at least find the x-intercepts, root 0 solutions. Those all basically mean the same thing. So find the x-intercepts and then go from there. So let us look at what that means. So number 1 is f of x equals 5 plus x. So you know that's a linear graph, hopefully. And let me adjust my window. Not that I really need to for this one. I'll keep it for now. But so you're looking at where is this graph above the x-axis? Where are the y values greater than or equal to 0? So from here and beyond. Now when you list your interval, remember again, we're talking x values. So that x-intercept is negative 1, 2, 3, 4, 5. So from negative 5, from x is negative 5 and beyond to infinity, my graph is on or above the x-axis. So negative 5 with a bracket in this case, comma, infinity. Because again, our y values are greater than or equal to 0 from negative 5 and beyond. So next graph, number 2, f of x equals x squared plus x. Oops, you should know this is quadratic. So I could have 2 possible locations where I'm above the x-axis, and since we have an a value that's a positive, that's typically going to be the case. So we're going to graph this, and it's probably kind of nice that my window is adjusted. Well, actually, don't really need it, so I'm going to go ahead and change it back to the original setting of 10. Now we're going to look at the graph to get kind of a closer look. Okay, so it looks to me like we have an x-intercept at negative 1 as well as 0. So I'm going to verify that with the table. So negative 1, 0, correct, and 0, 0, yes. So those are my x-intercepts. I just wanted to verify with the table. So where is this graph above or equal to the x-axis? Well, if I'm reading the graph left to right, from negative infinity to negative 1, negative infinity to negative 1, including negative 1 because my y value is exactly 0 at that point, and also from 0, the x value of 0, to infinity. Those are the places where my graph is above the x-axis. All right, last portion of today's notes, applications. So we're going to look at page 98, number 65 first. So I'm going to get this on the screen here, try and get both on the screen here. Number 98, or page 98, number 65. So the height y in feet of a punted football is approximated by this equation, where x is the horizontal distance in feet from where the football is punted. Okay, so this quadratic equation represents the path the football takes when punted. Okay, the y value, the y represents the height in feet, and the x represents the horizontal distance in feet. So part A, use a graphing utility to graph the path of the football. So we'll do that right now. So y equals negative alpha y equals 16 over 2025 x squared plus alpha y equals 9/5 x plus 3/2, which is just 1.5. I'm going to take the lazy way out on that one. Okay, so I've got my equation in. Now I'm going to graph. Probably the best idea to do right away will be to adjust the window. So of course I don't care about anything here to the left of the x-axis. So I'm going to adjust the window, and I don't need any negative x values. I'm going to go, let's say 100 feet is how far max a football would go, I think. So I'm going to scale by, do I want to scale by 5 or 10? I'll scale by 5. And then my y max, I'll also do, my min is 0, my y max is 100, and I'll also scale by 5. So let's take a look at that picture. Okay, so still not enough. Oops. So I'm going to double this, 200. I'm going to double this. I'm going to double this, and I'm going to double that. Looking a lot better. Okay, now I'm going to adjust just a little. I'm going to adjust this to 250. See what that does for me. So while that's going, I'm going to read. So I did part A. Let's look at part B. So part B says, how high is the football when it is punted? Okay, so that's right here if you can see the picture. So how high is the football when it is punted? Hint, find y when x equals 0. Okay, so my graph is finished here. So find y when x equals 0. So the easiest way to do that, in my opinion, is look at the table. Find y when x equals 0. Well, when x equals 0, it makes sense algebraically. If you plug in 0 here and 0 here, y is 1.5. Okay, so we already did part A. We will start listing part B. So part B is 1.5 feet. That's how high. Go back up and box these because that might drive me a little crazy. Okay, so my height when the ball is punted is 1.5, or the ball's height when it's punted is 1.5. That's part B. Part C, what is the maximum height of the football? Well, look at the graph. Let's do second trace 4 for that max. So left bound, see there. Right bound here, probably went too far. guess. So my maximum height, remember x is horizontal distance, my maximum height is about 104.016. Okay, so about 104.016 feet. So that's C, 104.016 feet. That's my local max, okay? So that's my local max via the calculator. And then, so that was part C. Now part D. How far from the punter does the football strike the ground? Okay, so how far from the punter, who is here, does the football strike the ground? So then in that case, we're trying to find this x-intercept here. So second trace, you could call it a 0, remember, so that's what we're going to find, the 0. Left bound, take a little while. So I'm going to do about here, and it's going to go off the graph to where I can't see it. I've punched a couple of times to the right, so I'm going to hit enter. So notice my 0, or my x-intercept, falls between my vertical lines, and I'll hit enter. And so about 228.643 feet. So part D, 228.643 feet.